Welcome everyone, and thank you for joining this webinar entitled Build Game-changing IIoT Apps in Days with Edge2Web for MindSphere. My name is Fred Holohan, and together with my colleague Eddie Budgen, our goal today is to walk you through a few introductory slides about Edge2Web for MindSphere, bring you through a short product demo, and then answer as many of your questions as time permits. Just a couple of housekeeping items. The webinar is being recorded for self-service viewing. If you have questions, you can type them into the Q&A window and we'll get to as many of them as we can. And then within the next few days, the recording for this webinar, the slides, and the full Q&A, whether we were able to answer all of the questions in this webinar or not, we will provide a complete written compendium of the questions and the answers on our website, along with the other content associated with this event. So let's jump right in. So as we look at this diagram here, this is actually a Siemens slide. We see that MindSphere is a best-in-class IIoT platform. Its primary job is to acquire, store, and provide access to all kinds of industrial data. Although MindSphere really shines in asset-intensive apps, it's also commonly used for discrete and continuous manufacturing, geospatial applications like supply chain management and mobile field service, and any application that requires analytics. The platform has some very nice analytics as part of it. So this is a very large diagram here. Probably what we should do is work from the bottom up. And doing that, we can see that MindSphere includes core data acquisition and storage. It also includes a very nice suite of analytic services, which you can see in that tier called Application Framework. We have several customers who are using those analytic services to do things like predictive maintenance and so forth. Moving up a little bit further, there's a set of core components with the platform for viewing assets and fleets and other type of relevant information. And then MindSphere, where the rubber meets the road in this webinar, MindSphere also includes an extensive portfolio of service APIs for building custom apps. And that's really what Edge2Web is about, allowing you to very quickly build custom applications on MindSphere. So this slide shows a very nice representation of the different types of platform services that are available in MindSphere. As we're going to discuss in a few minutes, Edge2Web supports all of the service APIs for MindSphere. So it's a very extensive degree of support. And basically, it gives you out-of-the-box connectivity to everything. Edge2Web does. So everything you see on the slide in terms of services and APIs is supported out of the box by Edge2Web connectors. One of the key takeaways as we look at the platform is that it is very large and very complex. So one of our goals is to allow you to utilize the full power of the platform without requiring you to master its complexity. So that was MindSphere. Let's jump in and take a quick look at who we are, Edge2Web as a company. I promise this will be very short, and then we'll get into product and demo. So this slide basically tells the story of Industry 4.0 or IIoT, or however you refer to it. Working from the left-hand side of the slide, you have some type of OT infrastructure. This could be a plant, it could be a wind farm, it could be a fleet of ships. Really, it's any infrastructure where data is flowing. And traditionally, data has been locked in this infrastructure, siloed, and not available to the rest of the business. What's happening now is important parts of that data are being replicated to the cloud, to something like MindSphere, and stored, and often the primary driver to get there is to do some sort of analytic on that data. Our thesis is that once the data finds its way into the cloud, it becomes democratized and liberated and available to the entire business for the first time. And so our products are aimed at allowing you to quickly use that data to do things you could never do before, build applications that were just not possible to do, and integrate those applications with other data stores and apps that run the business. This slide tells the story a slightly different way. If you look on the left-hand side, what you can see is that MindSphere and Edge2Web are generally industry agnostic. So we have shared customers with Siemens in many of the verticals that are listed on the left-hand side of the screen. Data gets fed from customer infrastructures into MindSphere, and then on the back end of that, customers use Edge2Web to build the kinds of applications you can see on the right-hand side of the screen. Listing of some of the enterprise accounts that are currently using Edge2Web on MindSphere. So very nice brands, not specific to any industry. You'll see aerospace represented here. You'll see pharma, you'll see food and beverage, consumer packaged goods, even agriculture, water management. It's really across the board. So what are some of these guys doing with Edge2Web for MindSphere? This slide just gives a quick representation of some of the brands you saw on that prior slide. Basically large customers located all over the place, building different types of applications, but you'll notice that there is a little bit of a theme here on the smart factory side. That just happens to be where we're seeing centers of gravity in adopting our product in the short term, but there are many other applications as well. And you can see on the right-hand side a short identification of some of the partners we're working with who are building applications on behalf of them, either themselves or their customers. So let's jump right into product. Edge2Web offers two products today, and we will release more over the coming 6 to 12 months. We have a pretty active roadmap, but the two products available today are Edge2Web Director and Edge2Web Flow Server. You use Director to build user-facing applications, and you can create many different kinds of user-facing apps. You use Flow Server to do heavy lifting type operations in the background. So think of batch data processing, where you have a technology that can pull data from MindSphere, integrate it with other applications, perform complex analytic pipelines, notify users if certain types of operating behaviors are out of range. So Flow Server does a lot of the non-visual heavy lifting work, and Director is the tool you use to put a face on that data. And also to provide users with interactivity, so if they need to input their own information, for example, from a plant floor, it's not uncommon for a plant engineer who's operating a line to want to adjust the scrap counts as a very basic example. Director can provide you with the capabilities to support that interactivity as well. In addition to the two main products, we have built and are continuing to build out a library of quick start components. These components are higher order application assets that you can use to immediately begin delivering value to your customers. So we have a custom asset management application. We've got a quick start for eventing and notification, a very nice quick start for spatial types of apps, data exchange, and so forth. We've co-built these components with our customers, and as a result, we have the ability to make them available to everyone for free. And so they're part of what you get when you take an Edge2Web subscription. I'm not going to go through the Director and Flow Server product slides in detail. They're in this deck so that you can refer to them later, but we'll actually see a lot of this in the demo that Eddie does. And so basically, Director provides you with many unique and innovative ways to very quickly create user-facing applications. And Flow Server does exactly the same thing for the non-visual stuff. The primary differences between these two products are that with Director, you can build screens and pages and publish them to human users, whereas with Flow Server, after you create a flow, you're scheduling that flow through the scheduler and viewing the execution of the flow through a series of logs. If we look at our products via a stack diagram, the gray area surrounding the blue stuff here, you can think of as MindSphere. And so MindSphere has many different types of service APIs. As I mentioned before, we take advantage of all of them, but working up, we're deeply integrated with MindSphere's identity and security system. We provide a very complete suite of in-the-box connectors that allow you to quickly connect to all of the different MindSphere services. Above connectivity is our orchestration tier. You use a flow editor, as Eddie will demonstrate for us. You learn to use that. It's very quick and easy to learn it, but once you know how to use it, then you can build applications for both user-facing purposes as well as back-end server-side operations. So really, once you learn how to use that flow editor, Edge2Web is very much of a learn once, use everywhere type of approach, and that flow editor is really the core to all of it. So if we go back and look at the MindSphere Service API diagram, we put Edge2Web in the middle of that because we can connect to all of those different services instantaneously. You get it right out of the box. As I mentioned before, it's not just query access. If you have to write things back to MindSphere, as you would need to do if, for example, you detected an out-of-range event, you would want to journal that event in the MindSphere event store so that you can do downstream analytics on that event itself. So to do that, you have to be able to write back to MindSphere, and we're able to do that. I mentioned quick start components, and this enterprise extensibility on the left-hand side here really is saying that we can, in addition to connecting to MindSphere, connect to any other data store that may be relevant for your application and any application that's accessible via standard REST APIs. So the path to getting an application into the hands of your end users looks in a very simplistic way like we're showing at the top of this slide. You build the app, you deploy the application, you publish the application to your end users, and then you manage the runtime operation of the application. Edge2Web makes this entire path easy and inexpensive. Those are really the key words to think of when describing what Edge2Web brings to the table. This slide and the one following is intended to back up what I just said. If you read from left to right on this slide, you'll see that the typical MindSphere application path is for a developer to subscribe to a MindAccess developer plan and a MindAccess operator plan. And the developer builds the application in this traditional approach somewhere to the left of this slide using a Java IDE or Mendix or something else. And if you're doing this approach, you build the application, you actually assemble it together into a build pack, and you push it into your dev tenant. Once you've tested it over here and you're happy with how things are functioning, you then deploy the application into a MindSphere operator tenant, and then you set up routes so that your end users who are going to be working in MindSphere IoT value plan tenants have access to your application and can run your application using their data. So this is the traditional MindSphere path. It's a pretty big footprint. It requires a pretty sizable team, and it's got a fairly hefty price tag associated with it. At Edge2Web, we take a different approach. We have deployed our tools and our runtime services into our own operator tenant. It's called Edge Opper. From here, we can provision a full set of tools and runtimes to your IoT value plan. So what this means is that you as a developer only need an IoT value plan to build, publish, and operate your applications because we're doing a lot of the heavy lifting for you in our operator. So the footprint is a lot smaller, the costs are significantly lower in this path, and you don't need nearly as big a team. We've got plenty of customers out there right now who have anywhere between 1 and 3 person teams building Edge2Web for MindSphere applications, and that's a pretty lightweight configuration. So we're going to change gears here and focus on pricing because that's a very important part of our story. Our thesis, our belief is that most of you out there are in the very early stages of IoT or Industry 4.0 adoption. And so our goal from a pricing point of view, from a business relationship perspective, is to make it very inexpensive for you to get started. And so we've implemented a pricing model. I'll just jump down to the director pricing. We've implemented a pricing model that's based on this notion of concurrent runtime users. That means these are floating licenses. So you can build and deploy an application to perhaps 15 users, it really depends on your profile, using a workgroup tenant, because all of those end users are not going to be active in the application at the same time, or it's unlikely that that would be the case. So this model gives you the ability to start out very small with a very inexpensive license, build your application, put it in front of your users, and as adoption grows, then you will come back to us to purchase additional floating runtime seats. And that's our belief in terms of how we will build our business. It's a shared success model, basically. And as you succeed and as your ecosystem adopts the Edge2Web applications you deliver to them, we will succeed right alongside of you. And that's really the model. So in summary, digital industrial apps are going to be wide-ranging across different industries and different ecosystems and stakeholders. These projects require a comprehensive platform, which MindSphere gives you, and best-in-class application development tools, which is what you get from Edge2Web. And that combination gives you the power to deliver applications today that you perhaps have never been able to deliver before. So having said all of that stuff, I want to hand things off to Eddie. This slide just gives you a picture of what you're going to see in the demonstration. So our demo scenario is a chemical batch manufacturing process. The process has got 4 stages. A reactor tank is filled with water. Material is injected into that tank with the water. The tank heats up and a mixer spins to mix the product up. And then once that process is completed, the product is offloaded to a storage tank. As you watch the demonstration, you're going to see 2 things. You're going to see Edge2Web Director visualizing the data that's already been loaded into the platform, but at some point in Eddie's demo, he'll show you the Edge2Web flow server flows that are used to generate the data and push it into MindSphere. So with that, Eddie, I would invite you to grab the screen away from me and commence with the demo.
Thank you, Fred. This is a dashboard for the batch chemical reactor, accessing the MindSphere IIoT data and presenting that data as a number of different visual outputs, or renderers as we call them. We have a couple of liquid gauges representing the respective tank levels for the reactor tank and the storage tank, and you may notice color changes as particular states are passed for each of the tanks. We have a time series of the reactor temperature along with its associated thresholds, as well as time series represented in a slightly different format with these 2 state diagrams. We have a tabular layout of unacknowledged events that have been recorded in MindSphere and associated with this particular reactor. Even though we're reviewing the detail of this reactor, it's perfectly reasonable to want to view a summary of associated equipment, in this particular case, a fleet of similar reactors. This gives the user the ability to drill into detail of one particular item while scanning the state of a number of others. An important aspect of user interactive dashboards is providing the ability for users to make changes to the view of the data that they have on display. This particular case with time series, it's relevant to offer a time selector. So we're giving a simple control that allows users to navigate to a different period of time in the past and to snap the dashboard back to a view of the time series and relevant data at that moment in time. I'm actually going to bring it back to a live view, still keeping with the hour, so we're now viewing an hour's worth of data, but sliding in real time. Another aspect of user interaction, potentially, is to update data or affect data in the MindSphere platform itself. In our case, we're allowing the user, via a selection of events that they have now noticed, to acknowledge those events and record that activity inside of MindSphere, post a confirmation by the user. So that is a representation of data being written back to MindSphere. As Fred had indicated, we have bi-directional access using the APIs that are available. In this case, we have updated the event with a new state. As we transition from the runtime environment to the designer environment, we will review the page, how it was created, and drill into one of the components to view the development process. Alongside that, we'll look at the background task that is evaluating the time series and potentially creating events based on crossing of various thresholds. So let's move to the designer. As a developer, I have aids obviously that allow me to navigate into the designer, and the initial page is presented as a static snapshot of the components that were in the runtime environment. Before getting into the page construction in detail, let's have a quick look at the designer homepage. Here we have the collection of all the work items in this director tenant, allowing a developer to both search and sort the items that they're interested in, as well as to be able to collect them together in a related project. It's from here they can also create new artifacts that are used in the application amongst the 5 classes that you see here. Language bundles allow you to provide a localized view of the screens delivered in the director application, such that a French browser could see the screen in French and a German browser in German and so forth. Themes allow you to apply consistent UI standards and styles across your pages, but also to provide dynamic theming should you wish to offer users the ability to change their own branding. Connections are the lifeblood of the data that flows through a director application, and you directly build connections to the existing services of your backend environment. Pages and flows make up the main part of the application logic. A page is the unit of publishing, as we were viewing in the dashboard for the chemical batch reactor, and a page is made up of one or more flows. You can consider the flow to be the unit of work that's published onto the page. With that, to add new content into a page, or as you start the page, it might be empty, you simply pick a location, click on a small link, it opens a blank cell, click on the blank cell, and you're invited to invoke a wizard-driven process to create a brand new component connecting to data, MindSphere in this particular case, or to retrieve an existing component that's been already developed by yourself or one of your colleagues. Again, I'm going to reverse my changes out. Once you have a page, either created completely or partially, you're going to want to be able to test it. We have a full runtime environment within the designer, which will allow you to run the page as if it was in the runtime environment, but provides an additional capability for the developer to view running live logs of each individual step that's being carried out in the various components, as well as to view the data in those components. And as this cycles through in different times, you'll potentially see different timestamps appear in the flows and so forth as they're repeatedly executing. Of course, debugging and testing is essential for development point of view. A couple of interesting characteristics of the page. You can have as many different data sources and data environments pulled into the same page. There is no technical limitation on having data within each cell from the same data source. So whether it's different data services in the same platform, as we're doing in this case with MindSphere, or multiple data sources being pulled together in the page doesn't care. Another important aspect is the ability to create both independent cells. They run in their own context. They don't have any inputs or outputs relative to other cells. Or, as in our case, using the time selector, we want the output from a particular cell that I've indicated here to be passed via the page, using the technology of the page, as input to the time series. What this allows me to do is to build a dependency between different pieces of logic in my page without the necessity to formally link them. It's a true service-oriented architecture that allows you to build the complex interaction of services on the fly. So they're not permanent except within the context of the page, and they require no program. It's also important to note that any of the cells on the page can impose their own refresh strategy. It wouldn't make sense to refresh the tank view every 10 seconds if the data in the MindSphere platform was being refreshed every minute, and vice versa. So each cell has the ability to impose its own refresh strategy, and in our case, we're indicating that we want the cell to refresh on the input change, which means I don't have a specific timer, but whenever any of the fields associated with the page change as my input, then I will refresh. And the key one here would be end time. So if I have the output from the timer being refreshed every 5 seconds, or when the user changes the date and time, then that will be the trigger to update and refresh the data in the tank. And again, you can build independent cells and components that do their own thing, or you can build dependency to build a holistic view of the data. Now let's drill into the reactor temperature time series and view how the development process was achieved. It's at this stage that developers would classically say, show me the code. Director is not a code generator or compiler or deployer. We provide an executable action model that is represented with a structured process diagram onto this canvas. You have the opportunity to interact with the actions wherever you like, to select, to potentially insert, or with the classic editing controls, Control X, Control V, to move and edit your flow around. This both increases the productivity for the developer, not having to join the logic steps on a blank canvas, and also reduces the risk of error. The grammar for the individual flow action steps is listed on the right-hand side, and I'll give a brief description in a moment. The principal navigation method throughout the product will be identification of the work item via a card or a tab in this particular case, a list of context actionable toolbar icons that will depend on what action you're trying to achieve, and then a set of properties, obviously very lightweight properties in this empty cell here. The types of actions that you can place on the diagram to operate are assign, where you're manipulating, editing the data as it moves through your flow. This could be calculations, this could be rearranging data structures, merging data structures from different areas, different fields. You can make calls to subflows. This will encourage productivity and reusability by encapsulating common patterns of logic and then providing them as their own microservice with their own inputs and outputs. Data service is the classic lifeblood of Director, where we interact with one of the connections and engage with a particular service operation to execute a call and receive data from an API or to carry out an update, depending on what the API is available to do. Decisions allow you to evaluate various equations at any point in the process and to be able to navigate to different logical paths depending on the outcome of that evaluation. Empty are placeholders, very much used in early documentation where you can use self-documenting labels to indicate what is supposed to happen in each place and then backfill with the actual actions as you need to. The end step allows you to exit the flow. You may have multiple exit points from your flow if you have multiple branches. Jump will allow you to navigate within the flow if you need to cycle through various calls within the flow or you need to skip various steps based on certain decisions. Notification will throw a toast notification to the runtime page that is visible to the user for a certain period of time. Parallel will execute independent logic paths in parallel, improving drastically the performance of your flow. The screen step will allow you to pause execution of the flow and to present a screen to the user. This could be for display purposes only, or more interestingly, to accept user input, as we did with the time selector on the runtime page. Another area of use of the screen is to provide buttons anywhere on the screen or in certain areas around the screen that will allow the user to navigate to other pieces of the logic of the application. This could be within the same flow or potentially to exit the flow and to move to another location. Now let's briefly review the logic and the execution actions used for the time series component. On the start step, you define your inputs and your outputs for the flow, i.e. what's going to trigger the flow as it initiates, and what are the eventual results that you wish to pass out of the flow. You can obviously have fields that go in and out, manipulated inside and then returned, as well as fields that are used just in the context of the flow itself. You can associate fields with a number of data types, both simple data types, charting data types, and also more complex data types associated with the MindSphere APIs or your service APIs if you're not using MindSphere. You don't need to define all of your fields at the beginning. You can, in fact, add fields at all the stages of developing the flow, and they are just associated and brought to the front. I'm going to jump to the end step to introduce how a screen is designed, and then we'll trace back through the logic to see how the data was generated that populates the screen. For developing a screen, we introduce a WYSIWYG editor that will be familiar to anybody who's used Microsoft Office tools. In here, I'm going to generate a new row in my table, enter into this, potentially change colors, add my own text should I need to, and you get the idea of being able to edit the layout of a screen. The moment you wish to visualize data from anywhere in the flow, be it from MindSphere or calculated derived data within the flow itself, you have a special toolbar icon that lists the number of fields. Selecting the right field will drop it into the position on the screen where the cursor was located and present you with its suggestion for a default renderer. I'm going to overwrite this and briefly view the list of visual renderers for data that you can use. There are 30 renderers in Director, allowing for different visual outputs of the data within your application. Whether you're interested in charting, graphing, time series graphs, donut charts, and so forth, you have a multitude of renderers, each with their own set of display properties that then you can fine tune. A number of the controls are in fact destined for user input. So the ability for the user to enter data into the screen, which can be further used in your logic to do some calculations, to navigate to other locations in the application, or potentially direct data that you may end up inserting back into MindSphere. One renderer of particular note is the flex list. In many cases in the industrial world, you'll be monitoring more than one item, such as we had 3 reactors on our dashboard. The flex list allows you to handle any number of items of the same type, to provide them as a list, and then to have each of the processing done in parallel, and then each card for each item is presented in a graphical form. So as in our case, we had a brief view of 3 reactors with their current state and a batch number. That could have been a small time series graph, it could have been an area chart, it could have been a donut chart. There is actually no restriction on the visualization of the data for each element of the list. In fact, you're able to provide logic that would allow you to output the content of a flex list with different visualizations. So you could absorb a list of different types of activity, and they would just show as different cards depending on how you process their particular logic. The flex list itself runs in parallel, so is optimized for performance. You can also interact with it if you have access to GPS coordinates, as you do in the MindSphere asset library, if you're input. You can then place the assets directly onto a Google sitemap that would allow somebody to provide navigation and zoom and location using normal mapping technology. We also have the ability to drop the assets and the data onto a diagram, a floor plan, or even a photograph of the actual equipment that's being monitored. This is sometimes an aid to give a physical clue to where a particular variable is potentially being monitored, maybe even indicating alerts and so forth. So the flex list provides a very powerful and flexible way to handle fleet operations and to represent a cohesive list of visualizations for the multiple assets that you may be managing at one time. Each individual renderer provides its own set of display options that can be configured individually and are set, in fact, via the themes. So in reference to an earlier part of the demonstration, you can create a theme that would override the defaults, that would apply your own styling to almost every element of the visual renderer. Having developed a screen using a visual designer, this doesn't preclude the developer being able to very fine-tune the HTML source code that is involved in creating the screen. The individual data renderers are taken care of by the rendering technology we have, but the frame of the screen and any styling that may be beyond the capabilities of the visual designer can be incorporated by editing the HTML directly, returning to the visualization, and then saving the screen. Now we'll review the action model that was used to generate the data that was presented in the screen. The first step is an assign step used to manipulate data. In this case, it is a simple mathematical formula, subtracting 2 variables, to produce a number that will be placed into the start time field. This introduces the only programming language that you will need in building Director applications, JavaScript. JavaScript is a very common language used for data manipulation in web-based technologies, very accessible to developers, but also non-developers. Anybody who can read, write a Microsoft Excel macro will be perfectly capable of being able to read and be able to generate their own JavaScript to manipulate the data if they need to do that. The next step is a parallel step, executing multiple branches, 2 in our case, simultaneously. The first branch, the top branch more than the first branch, is calling on a subflow. In this case, it's calling on one of our system flows. I'll just navigate to that. System flows are a collection of utilities that represent very common integration patterns with certain of the MindSphere API services. The specific one for retrieving time series and time series aggregate information is used extensively in almost all Director applications. We provide the system flows as read-only flows, but you can simply take a copy using save as, create your own version of the flow, and then extend or change any behavior that you like of any specific flow as we provide you with the source code. Returning to the master flow, in our case, the second branch represents a more direct interaction with one of the MindSphere API services. In this case, we're engaging through the connection to the MindSphere events service. MindSphere has an extensive set of event management capabilities. Once selected your connection, you would then be offered the specific service operations that you can choose from. In our case, we're actually going to look for finding events, but we may have been interested in creating or deleting or updating other events. Once you select your service operation, you're provided with a list of the API input parameters and then the ability to enter in your own content that will be sent to the MindSphere call as you execute this flow. In our case, we've entered in a value of 100 to limit the number of events that might be returned, and also applying a filter that itself is used in a dynamic fashion using JavaScript to generate a dynamic content for the filter. In this particular case, we're actually working on some dates and then providing some key information about the asset and what type of event that we're actually interested in. The next step is the dummy empty step that I dropped onto the screen. I'm going to change this. I'm going to change this step type into a screen. The screen is used to pause the flow and present a screen to the user. This could be to show particular data to a user as part of a flow of information that you wish to display, or could be used to retrieve input from the user. That input may well be to enter in specific data that you may use later in the flow. In this case, I'm going to set an input field that would request the user to input a field called start time and provide an input control of type date and time with any configuration of the display options that would suit my desired output. You can also introduce choices of navigation for the user by introducing additional answers. For instance, I could introduce a cancel answer and simply change the second branch of the flow to be an end step, for example. Or we could have other branches that do other work and actually build logic that might be more complex in its nature. So in this case, I could type in here, more work and do additional flow steps and so forth. The last two steps of our example flow are again assigned steps, which allow for data manipulation. Very brief look at this one. Provides more complex JavaScript, in this case to make certain tests and then loop through the data structures for events to extract a particular event so that I can structure it to be presented in a time series. I've used this to show that beyond being able to use simple mathematics using JavaScript, you can actually use all of the sophistication of the data manipulation language should you need to do so. Following that, I'd like to move to the flow server, having completed the review of the flow itself. The flow server provides server-side data orchestration tasks that can be scheduled to run at a specific frequency or at a specific time of the day. The tasks are set by selecting a flow, providing a unique task name, and the reason we have this is that you can run the same flow with multiple inputs to provide you different context for the execution of the flow. You then indicate the frequency that you'd like to run the flow, or for a particular, using the cron expression, for a particular part of the day or hour. And you can indicate the level of logging that you wish to output in the flow server. The logs contain a summary view of the inputs and outputs of each instance that the flow is executed according to the timer that we just set. The flow itself is identical in its development design and development process as any other flow that we had seen in Director. The only difference is that the screen step is not available to the flow server flows. Fairly obviously, there is no user sitting in the server and no ability to pause and request input. The flows themselves contain exactly the same grammar and exactly the same approach to managing the data. In this case, we're retrieving a time series segment from MindSphere, examining the return data against an anomaly analysis model within MindSphere. Should any anomalies be found, we're generating the payload to create the event dynamically using JavaScript, and then providing an output status and potentially showing an end screen. For design purposes, this screen would not be shown in the runtime environment on Flow Server. And with that, I'd like to conclude the demonstration and hand you back to Fred for conclusion and questions and answers.
This has been great. I appreciate everyone's time and attendance at the live event. Thank you very much for coming and look forward to working with you over the weeks and months to come. Thanks very much.